So as we develop the filters, one of the key components that we have to look at is what we call the beta ratio. Now, a beta ratio is how efficient a filter is at controlling the contamination. When we talk about beta ratios, I'll always start with what we call competitive nominal. So when you have a filter, you're testing it, 3,000 particles are introduced to that filter, 5 microns and larger. Now remember, as we talked earlier, 5 microns is a very small contaminant. 3,000 particles introduced, 1,500 particles come out on the clean side. So as you do the beta ratio, it's 3,000 divided by 1,500 equals 2. So that's a 5 micron beta, 5 micron beta, 2. So what we call a beta 2. Let's put that into efficiency. Now 1 minus 1 divided by the beta ratio. So in this case, 1 divided by half. Efficiency is 50%. So that filter is only capable of 50% efficiency at that specific micron size you're targeting. When we talk about our corporate filters, we run through the same testing. 3,000 particles are introduced at 5 micron and larger. 40 particles come out. So the beta ratio, 3,000 divided by 40, 75. So it's a beta 75. When we put that into efficiency using that same math, 98.7% efficient at pulling the contaminants out. So when you hear a competitor talking about their filters, they'll say, FG Wilson says this has to be a 5 micron filter. We have a 5 micron filter as a replacement. The question that always needs to be asked is, how efficient is that filter? Because at minimum, the corporate filters are 98.7% efficient or better. Many cases will have beta 200, 99.999% efficient, or even higher than that. Minimum we always cover is 98.7% or better. So when they talk about 5 micron to 5 micron, it's not always the same. How efficient is that filter at pulling those contaminants out? Also, how efficient is that filter over time at pulling those contaminants out? We want to ensure that you get the best value over time for your machine, and we're going to protect it the best that we can over time.